everyone. We are the Group 5, and our topic is all about unit rates or constant change of rate.
And unit rates is also ratios between two different units with a denominator of 1 per 1 unit. Here are two examples of unit rates that make a complete sense on what I mean about per 1 unit. Number 1, here we have 30 miles in 2 hours. We need to find how many miles there are per hour. 30 miles in 2 hours, miles per hour. So we find the unit rate by writing out our ratio as a fractions. So we have 30 miles per hour, 2 hours. So what we need to do, we need to get denominator of 1 that's going to give us per 1 hour. Also, in order to get a denominator of 1, we divide it by 2. And with fraction, in order to keep that equivalent, we don't change the value of whatever we do to bottom. We must do the top. So we divide 30 by 2. That will keep everything equivalent and give us the unit rate because we'll have a denominator of 1 now. So now we have 15 miles per hour, 1 hour, or 15 miles per hour. So we got 30 miles in 2 hours. Number 2, 40 apartments on 5 floors, apps per floor. So we're gonna find how many apartments per floor. So again, let's start up with a fraction. 40 apartments and 5 floors, so we need to find out how many apartments in 1 floor. So we need to find out how many apartments in 1 floor. So again, we need a denominator of 1. So we do that by dividing both our numerator and denominator by 5. Again, I choose 5 to get the numerator to equal. We got 8 apartments per 1 floor. 40 apartments on 5 floor equals 8 apartments per hour or per 1 hour. Moving on the next topic, we have constant change of rate.
What is constant change of rate? Rate of change is a rate that describes how quantity change in relation to another. In a linear relationship, the rate of change between any two quantities is the same. The linear relationship has a constant rate of change. So, here we have a world link. A computer programmer charges customer per line of code. We will fill in the blank with the amount of change between consecutive numbers. 50 to 100, that is increasing by 50. From 100 to 150, that is also increasing by 50. From 150 to 200, that is also increasing by 50. What about 1,000 to 2,000? 2,000 to 3,000, and 3,000 to 4,000. Those are increasing by 2 each time. And so let us label the diagram below with the term change of line. Change in dollars and constant rate of charge. The $100 represent the two. This is going to be changed in dollar. So write the change in dollars, and then 50 lines will that plus 50. That our change in lines. And now, you can see where you simplified 1,000 over 50. Lines down and $200 per one line. We have one more blank and one more set of words. The constant rate of change. This $20 for lines in programmer's code. And moving on to the example of constant change. So here we will use a table to find the constant rate of change.
The amount of money of booster clubs, make wash up of freezer. Use the information to find the constant rate of change in dollars per car. We are going to be setting up and finding the unit rate dollars per car, but the first thing we're going to do is look for the change or change from the number of cars from 5 to 10 is 5, from 10 to 15 is plus 5, from 15 to 20 is plus 5. All constant changes. From 40 to 80, we're adding 40. From 180 to 120, or adding 40. From 120 to 160, we're adding 40. So the next step is to find the unit rate to determine the constant rate of change. And when determining what goes on, look back at our questions. Dollars per car, and this set up change money, our dollars over our change in car. So dollar per car help us set up the unit rate. So our change in money was $40. Our change the number of cars was 5 cars. So $40 over 5 car is our constant rate of change, and we can simplify that by dividing by 5 on top to bottom. $8 per car. So the number of dollars earned increases $8 for every car wash.